Hello student, in today's session I am going to discuss biomolecule. This biomolecule is present in CBSE Class 12 syllabus. It is present in NEET and JEE-MAIN syllabus. So at the end of this video, I will provide you with a list of questions which has appeared in CBSE in the last 10 years, and I will also provide a list of questions which has appeared in the NEET and JEE-MAINs in the last 10 years. And I believe that if you go through this video without skipping, you will be able to solve all the questions which has appeared in the last 10 years of CBSE or JEE or NEET. So without wasting time, let's start with our topic, biomolecules. Biomolecules. The chapter has got three major topics. The first one is carbohydrates. The second one is proteins, and the third one is nucleic acid. Now in this video I will discuss only about carbohydrates. So let's start with carbohydrates. The term carbohydrate has got two terms, carbo and hydrates. Carbo and hydrates. So we can define carbohydrates as hydrates of carbon atom, with general formula CxH2O whole Y. Now there are many compounds which fit in this general formula, but still they are not carbohydrates. For example, when X is equal to 1 and Y is equal to 1, we get HCHO, which is formaldehyde. When X is equal to 2 and Y is equal to 2, we get CH3COOH, which is acetic acid. And there are some carbohydrates which does not fit in the general formula. For example, rhamnose. It has the molecular formula C6H12O5, and so it does not fit in the general formula. But if you talk about glucose or fructose, which has the formula C6H12O6, it very well fit in the general formula. Now we will define carbohydrate. Now the way we have to write in the CBSE board exam. So carbohydrate, how we are going to define it in the board exam? Carbohydrates may be defined as optically active polyhydroxyaldehyde or ketone. Carbohydrates are optically active polyhydroxyaldehydes or ketone, or compounds which produces such simple unit upon hydrolysis. Such unit means those molecules which produce polyhydroxyaldehyde or ketone can also be classified as carbohydrate. Next we will move on to the classification of carbohydrates. Before that, let me tell you, there are certain carbohydrates which are sweet in taste and hence we call them sugar. Now in Greek, sugar is named as saccharide. So these carbohydrates are classified on the basis of number of simple saccharide. So this is our first classification. classification based on the number of simple polyhydroxyaldehyde or ketone that is obtained upon hydrolysis. So the first classification is monosaccharide. Saccharide, monosaccharide. What a monosaccharide? Carbohydrate which cannot be further hydrolyzed. Carbohydrates which cannot be further hydrolyzed into simpler polyhydroxyaldehyde or ketones. Okay, carbohydrate which cannot be further hydrolyzed into simpler polyhydroxyaldehydes or ketone are called monosaccharide. Example: glucose, fructose, ribose, etc. Next is oligosaccharide. Saccharide. Saccharide. Oligosaccharide. Carbohydrate which upon hydrolysis produces 2 to 10 monosaccharide. Carbohydrate which upon hydrolysis produces 2 to 10 monosaccharide are called oligosaccharide. For example, if a carbohydrate produces 2 monosaccharide, we call it disaccharide. If it produces 3 monosaccharide, we call it trisaccharide. If 4, then tetrasaccharide. Example: sucrose, then maltose, then lactose. So all these 3 oligosaccharide, they belongs to disaccharide because sucrose is made up of glucose and fructose. Maltose is made up of glucose only, 2 glucose unit. Lactose contain galactose and glucose. Next we will move on to polysaccharide. Carbohydrate which upon hydrolysis produces a large number of monosaccharide. Which upon hydrolysis produces a large number of monosaccharide are called polysaccharide. For example, starch, cellulose, glycogen, etc. Next we will move on to the second type of classification, because there are certain carbohydrates which are mild reducing agent. Mild reducing agent means they can reduce mild oxidizing agent like tolerance reagent, like failing solution. So those carbohydrates are called reducing sugar. So next classification is on the basis of reducing character. The second classification is on the basis of reducing character. One we call reducing sugar, another is called non-reducing sugar. So in exam, how we are going to define them or how we are going to differentiate them? Reducing sugar, those carbohydrates which contain free aldehyde or keto group, those carbohydrates which contain free aldehyde or keto group can reduce tolerance reagent or failing solution and hence are called reducing sugar and hence are called reducing sugar. Okay, so those carbohydrates which contain free aldehyde or keto group can reduce tolerance reagent and failing solution are called reducing sugar. For example, all monosaccharide. Example, all monosaccharide. Monosaccharide. S-A-C-C-H-A-R-I-D-E. Monosaccharide. In case of disaccharide, this lactose is a reducing sugar. Maltose is also a reducing sugar. Now next move on to non-reducing sugar. The definition will be similar. Those carbohydrates which does not contain free aldehyde or keto group cannot reduce tolerance reagent or failing solution and hence are called non-reducing sugar. So write it. Those carbohydrates which does not contain free aldehydes or keto group cannot reduce tolerance reagent or failing solution and are called non-reducing sugar and are called non-reducing sugar. For example, sucrose. Write down the example. Example, sucrose. Afterward, I will tell you why lactose and maltose are reducing sugar while sucrose is non-reducing. All this lactose, maltose, sucrose all are disaccharide, but these two are reducing and sucrose is non-reducing. That we will discuss afterward with the structure where there is free aldehyde or there is no free aldehyde or keto group. So next we will move on to the classification, the third classification, which is based on the number of carbon atom and the functional group, whether it is aldehyde or ketone. The third classification is based on the number of carbon atom and on the number of carbon atom and the functional group. Classification. So if you take the number of carbon atoms here, the general name, if aldehyde functional group is there or if keto functional group is there, then how we classify them? If the number of carbon atom is 3, that is 3 carbon, C3, we call it triose. If there are 4 carbon atoms, tetrose. If there are 5 carbon atoms, pentose. 6 carbon atom, hexose. Now, if that triose or tetrose or hexose contain aldehyde group, we call it aldotriose. We call it aldotetrose. or like that aldopentose, then aldohexose, like this. Ketone, these are similar, ketohexose, ketopentose, ketotriose, like this. Now, example of aldohexose is glucose. Glucose is an example of aldohexose, whereas fructose is an example of ketohexose. Then ribose, it is an example of aldopentose, ribose, which is present in RNA, that is ribonucleic acid. Okay, since we have completed the classification, next we will move on to the preparation of glucose. So next is preparation of glucose. Preparation of glucose. Now, glucose can be prepared in laboratory by hydrolysis of sucrose. So, the first preparation is hydrolysis of sucrose. Okay. Sucrose, we know the formula C12H22O11. This upon hydrolysis with water in presence of H plus ion or in presence of an enzyme called invertase, it is converted into C6H12O6 glucose plus C6H12O6 fructose. This glucose and fructose, they have the same molecular formula. The only difference is one is aldehyde, another is ketone. Now this reaction you have studied in chemical kinetics. This is an example of pseudo first order reaction. Pseudo first order reaction. Because here water is present in large excess. Second, glucose is prepared in industry by hydrolysis of starch or cellulose. Hydrolysis of starch. Now, how to memorize this equation? It seems little difficult, but actually it is not difficult at all. The final product which you are getting is glucose, C6H12O6. Okay. So you will be getting n number of C6H12O6 because starch is a polymer of glucose. It's a polysaccharide. So we will write here, since we are doing hydrolysis, n number of water. Now water contains 2 hydrogen and 1 oxygen. So you will write the formula of starch like this: C6H10O5 whole n. So this is starch. Starch upon hydrolysis, it produces C6H12O6, that is glucose. How I memorize this equation? I simply write glucose first and then I write the water. The number of carbon and hydrogen I adjust according to the glucose. Glucose contains 6 carbon. Okay, I keep 6 carbon. Now glucose contains 12 hydrogen. I keep it here 10 because 10 plus 2 is 12. Glucose contains 6 oxygen. Here we are having 5 oxygen. 5 plus 1, 6. So it is balanced. Next topic is very important, that is structural elucidation of glucose. Now what is meant by structural elucidation? It is nothing but structure determination. The structure of glucose was determined long back when the technology has not advanced to that level. because nowadays when we have to identify or when we have to determine the structure of any compound, we do NMR study, we do mass spectrometry, IR, UV, all these techniques we use. But at that time, all these techniques were not available, and scientists had deduced the structure on the basis of chemical reaction. So we'll learn in how they have deduced the structure of glucose from chemical reaction. So next is structural elucidation of glucose. Give the heading structural elucidation of glucose, or you can simply write structured determination of glucose. Okay. Now the first reaction is reaction with HI. Reaction with HI. This HI is a strong reducing agent. So whenever glucose CHO, CHOH, this is glucose. This glucose when treated with HI excess, it produces CH3, CH2 whole 4, CH3. This is N-hexane. So upon reduction of glucose with HI, we get N-hexane. N-hexane means there is no branching. It's a straight chain compound. So from this reaction, we can suggest that glucose is a straight chain compound. So this indicate or confirm that glucose is a straight chain compound. Okay, this indicate or confirm that glucose is a straight chain compound. Next we will move on to the second reaction. Reaction with hydroxylamine and reaction with hydrogen cyanide. Reaction with hydroxylamine, that is NH2OH, and with hydrogen cyanide, HCN. So what happens when glucose is treated with hydroxylamine? CHO, CHOH, whole 4, CH2OH. This upon reaction with HCN, it will produce CH, CN, OH, CHOH, whole 4, CH2OH. This is called cyanohydrine. If it reacts with hydroxylamine, NH2OH, then it produces CH double bond N OH, CHOH whole 4, CH2OH. This is called oxime. So what does this reaction suggest? This reaction suggests that glucose contain a carbonyl group. Glucose contain a carbonyl group because this hydroxylamine and HCN, these are specific for carbonyl compound. Next reaction. Now we got that glucose is having a carbonyl group. Now we have to prove that the carbonyl group is an aldehyde group or a keto group. So what we do, or what scientists had done at that time, they had oxidized glucose with a very mild oxidizing agent. That mild oxidizing agent is bromine water, Br2H2O. So this is converted into CHOH whole 4 CH2OH. This is called gluconic acid. And this reaction suggests that the carbonyl group is an aldehyde one. The carbonyl group is aldehyde group. And not ketone. The fourth reaction is reaction with acetic anhydride. CHO, CHOH whole 4 CH2OH. When treated with acetic anhydride, CH3C double bond O, OC double bond O, CH3. This is acetic anhydride. It produces a compound like this, CH OC double bond O, CH3 whole 4, CH2O, C double bond O, CH3. This is called pentacetate derivative. This is called pentacetate derivative. This reaction suggests that glucose contain 5 OH group. That's why we are getting pentacetate. 5 OH give 5 acetate. Glucose contain 5 OH group. Next reaction, the fifth one. The fifth one is reaction with nitric acid. Reaction with HNO3. Usually dilute nitric acid is enough to do the reaction. See, if you are having say glucose, CHO, CHOH, CH2OH. This is whole 4. Add nitric acid, HNO3. You will get COOH, CHOH, whole 4, COOH. A dicarboxylic acid is formed. Even this dicarboxylic acid can be obtained from the monocarboxylic acid, which we have got in the bromine water reaction. This is gluconic acid, the monocarboxylic acid. This also upon oxidation it produces the dicarboxylic acid, which is called glucaric acid or saccharic acid, or it is called saccharic acid. SACCHARIC, saccharic acid. Now what does it suggest? This reaction suggests that glucose contain one primary alcohol group. Glucose contain one primary alcohol. Primary alcohol group. The rest other alcohols are secondary. There is only one primary alcohol. This is suggested by this reaction. In your CBSE exam, you will get question, give the reaction which suggests the presence of a aldehyde group, which suggests the presence of a 5-OH group, which suggests the presence of a primary alcohol group. So like this you have to write the chemical equation. Next is why glucose is called D plus glucose. Why glucose is called D plus glucose. Okay, this we have to understand. This capital D, this says relative configuration of the C5 carbon atom. Relative configuration of C5 atom. And this plus sign, it gives the specific or optical rotation of glucose. Plus means dextrorotatory, minus means levorotatory, and this optical rotation has nothing to do with this term capital D. Now how this term capital D arises? There is a configuration called relative configuration and absolute configuration. The relative configuration, we use D and L system, and in absolute configuration we use R and S system. Okay. Now in this video I will tell you about D and L. CHO, OH, H, CH2OH. This is the smallest carbohydrate, glyceraldehyde. Glyceraldehyde has got two enantiomer or enantiomeric pair, CHO, OH, H, CH2OH. Now, whenever this OH group is on the right hand side, we call it D-glyceraldehyde, and whenever this OH group is on the left, we call it L-glyceraldehyde in the Fischer projection formula. This formula are Fischer projection formula. So whenever in a Fischer projection formula, if the heteroatom, the O, oxygen or the OH group is on the right hand side, we call it D-glyceraldehyde. If it is on the left hand side, we call it L-glyceraldehyde. Now we will write the structure of glucose and we will see whether the OH is on the left hand side or right hand side. Now before that, we should number the carbon atom. We all know the aldehyde group should get priority. So the aldehyde carbon is the first carbon, this is the second carbon, and this is the third carbon. So it is the second last carbon whose configuration is being taken. So in glucose also we have to check the configuration of the second last carbon atom. CHO 2, 3, 4, 5, 6. Like this I remember. You should remember like this. Now how to put the OH group? The simple concept, you will put the OH group from bottom to top. How? Right, right, left, right. Right, right, left, right. Right, right, left, right. This is how I memorize. Right, right, left, right. So again, if you number the carbon atom, 1, 2, 3, 4, 5, 6. Now the second last carbon, the last carbon is this one and the second last carbon is this one, that is C5. In the C5 you can see the OH is on the right hand side, hence we call it D-glucose. Hence we call it D-glucose. Let's see the structure of D fructose. As I told you, fructose and glucose, they have the same molecular formula, but glucose has aldehyde group and fructose has a keto group. So fructose, CH2OH, C double bond O, third, fourth, fifth, and this one is the sixth one. So again the same concept, right, right, left. There is no more right. Right, right, left. Right, right, left. No more right here. So again, if you number the carbon atom, 1, 1, 2, 3, 4, 5, 6. As you can see, the fifth carbon, the OH is on the right hand side, hence it is called D fructose. So we have learned why glucose is called D plus glucose. D is due to the relative orientation of OH group. If the OH is on the right hand side, we call it D. If the OH is on the left hand side, we call it L. And the plus and minus, they are all about optical rotation of the glucose or fructose. For example, if you consider fructose, it will be D minus fructose, because fructose rotate the plane polarized light to the left, and hence it is a levorotatory. Whereas glucose rotate the plane polarized light to the right, hence we call it dextrorotatory. Okay, so glucose is dextrorotatory, fructose is levorotatory. Remember this thing, because again we need this knowledge, levorotatory, dextrorotatory, in our further discussion. Okay, next we will see the cyclic structure of glucose, and before that we should know why we are going to study the cyclic structure. Now come to the cyclic structure of glucose. But why we should study the cyclic structure? Why? We should know why we are studying this cyclic structure. The first point is glucose does not give sodium bisulfite addition product. Glucose, D-glucose, does not give or does not react with sodium bisulfite. Second point, D-glucose does not give 2,4-DNP test. D-glucose does not give 2,4-DNP test, or it does not give even the Schiff's test. The 2,4-DNP test is specific for carbonyl compound, whereas Schiff's test is specific for aldehydes. The third one, the pentaacetate form of D-glucose does not react with hydroxylamine NH2OH. The pentaacetate form of glucose does not react with hydroxylamine. And the fourth one is the phenomenon of Muta Rotation, which I will discuss afterward. Phenomenon of Muta Rotation. Okay. And the fifth point is, on reaction with 1 mole of methanol, CH3OH, D-glucose produces 2 methyl glucoside, that is methyl alpha D glucoside and beta D glucoside. Alpha D glucoside and methyl beta D glucoside. Now this alpha beta I will explain in detail. What is alpha, what is beta, what is Muta rotation, all this term I will explain. Now because of all this reason we have to study glucose, the cyclic structure of glucose, because the open structure, if it exists, then the molecule should give all this reaction. Since the molecule is not giving all this reaction, then there must be a cyclic structure which has been formed due to reaction between the aldehyde group and the OH group. So let's see how the structure is formed, the cyclic structure. Now glucose exists in two crystalline structure, but crystalline form. Glucose exists in two crystalline form. Alpha D glucose, which has a melting point of say around 419 Kelvin, and beta D glucose, which has a melting point of 423 Kelvin. There is a slight difference in their melting point. These two crystalline form of glucose has been observed. Now, it has been observed that the two form of glucose are interconvertible in solution, in aqueous solution. So, in aqueous solution, if you are having alpha D glucose, then it will be converted into beta D glucose, or if you are having pure beta D glucose, then it will be converted into alpha D glucose through a open chain system. So first of all, we will draw the open chain structure and then we will draw the cyclic structure. CHO 2, 3, 4, 5, 6. The lone pair on the oxygen atom of the fifth carbon atom will attack this carbonyl carbon. Right, right, left, right. So remember it like this. This is the open chain structure. Open chain. Now due to this attack, it will form a cyclic chain due to attack from a OH group to the CHO group, and this will give a hemiacetal linkage. See, OH, H, 2, 3, 4, 5. In case of fifth one, we put the oxygen like this. Right, right, left, right. Okay. So in this case, you can see the OH on the first carbon, 1, 2, 3, 4, 5, 6 is on the right hand side, and we call it alpha D glucose or alpha form. In the second case, CHOH 2, 3, 4, 5. In case of fifth one, you put a bond like this, CH2OH, right, right, left, right. So you can see the OH is on the left hand side and we call it beta form or beta glucose. So these two are the cyclic form of glucose, alpha glucose, beta glucose, they exist only in the crystalline state or in the solid state. The moment you add them in water or you take aqueous solution, the alpha glucose is converted into the open chain, which then finally convert into beta glucose. Or even if you take beta glucose, it will convert into the open chain and then into alpha glucose. So there exists an equilibrium between the alpha form and the beta form in aqueous medium, not in the solid state. Now, because of this equilibrium between the alpha form and beta form, the phenomenon called Muta Rotation takes place. So next we will discuss what is Muta Rotation. This alpha D glucose, if you measure the optical rotation of alpha D glucose, pure alpha D glucose, if you measure the optical rotation of alpha D glucose, then it's come out to be plus 109 degree. If you measure the optical rotation of beta D glucose, it comes out to be plus 19 degree. Plus 19 degree. And when you start with alpha D glucose and you start with beta D glucose, ultimately you move into a equilibrium mixture. Isn't? You move into a equilibrium mixture. The equilibrium mixture has an optical rotation of 52.7 degree. It is plus 52.7 degree. It should be plus 52.7 degree. This is simply the sign for specific rotation or optical rotation. No need to memorize this D and T. D actually it is decimeter, T is the temperature. This you don't have to memorize. Plus 52.7 degree. Okay. So whenever we start with pure alpha D glucose or pure beta D glucose, ultimately we get a equilibrium mixture whose optical rotation is 52.7 degree. Pure alpha D glucose has optical rotation 119 degree. Beta D glucose has an optical rotation of only 19 degree. Okay, this phenomenon is called Muta Rotation. This phenomenon is called Muta Rotation. So let us define the term Muta Rotation. Lekho, write down. The decrease in specific rotation of alpha D glucose and the increase in specific rotation of beta D glucose to a equilibrium value of 52.7 degree is called Muta Rotation. The decrease in specific rotation of alpha D glucose and the increase in specific rotation of beta D glucose to a equilibrium value of 52.7 degree is called Muta Rotation. Is called Muta Rotation. So what is Muta Rotation? Write it down. The phenomenon of change in specific rotation, change in change in specific rotation of pure alpha D glucose or pure beta D glucose to a equilibrium value is called Muta Rotation. Is called Muta Rotation. Next term we will discuss anomers. Next term is anomers. Now, if you observe this alpha D glucose and beta D glucose, you will find there is change only in the C1 carbon atom. 2, 3, 4, 5 and 6. So in the alpha D glucose, the OH on the C1 is on the right hand side. In beta D glucose, the OH is on the left hand side. So there is change in configuration of only one carbon atom. Such isomers are called anomers. So how we will define? Isomers which differ in the configuration of one carbon atom are called anomers. Isomer which differ in the configuration of one carbon atom, that is C1 carbon atom, is called anomer. And this carbon, that is the first carbon, C1 carbon, is called anomeric carbon atom. Anomeric carbon atom. The C1 carbon atom is called anomeric carbon atom. And the two isomers alpha and beta form are called anomers. Alpha and beta form are called anomers. Now we have learned the cyclic structure of glucose. Now the cyclic structure of glucose is best presented by Haworth's structure. This we have drawn the Fischer projection structure. Next we have to learn what is Haworth's structure. Or you will get question in your CBSE exam. What is meant by Pyranostructure structure of glucose? What is meant by Furanos structure of glucose? And that Pyranostructure structure and Furanos structure, those can be studied from the Haworth structure. Haworth structure. Or you will be asked what is meant by Pyranostructure structure? Pyranostructure structure of glucose. Okay, first we should know what is pyran. Pyran is a 6-member heterocyclic compound. This is called pyran. 6-member heterocyclic compound. Now the 6-member cyclic chain of glucose is called Pyranostructure structure. First of all, we will draw the normal structure. Say this one, COH, H, second, third, fourth, fifth, and this one is the 6th one. Put the oxygen here like this. Right, right, left, right. Okay. Now we will draw the Pyranostructure structure. This is the Pyranostructure structure. Now here, this one is the first carbon atom, C1. This one is the second carbon atom, third one, fourth one, fifth one. So number it. This one also. This is alpha glucose or alpha D glucose. 1, 2, 3, 4, 5, 6. Now on the first carbon, the OH is on the right hand side. So you will put the OH below and the H above. The right group will be below and the left group will be above. So write below. Write below. This is the rule. Write below. The second one, OH, H. The third one, H, OH, because OH is on the left hand side. The fourth one, right hand side, OH, H. The fifth one, in the fifth one, remember to put the CH2OH above. That's all. So this structure is called Pyranostructure of glucose. This structure is called Pyranostructure of glucose, or we call it alpha D glucopyranose. So in your board exam, how we will define what is meant by Pyranostructure of glucose? Write down. The 6-member cyclic structure of glucose. The 6-member cyclic structure of glucose. The 6-member cyclic structure of glucose formed by hemiacetal linkage between C5OH group and C1CHO group is called Pyranostructure. Because this structure is formed by the reaction of alcoholic OH with aldehyde group. The reaction of alcohol, 1 mole of alcohol with aldehyde is hemiacetal. If 2 mole of alcohol react, we call it acetal. So this is basically a hemiacetal linkage. The 6-member cyclic structure of glucose formed by hemiacetal linkage between C5OH, C1CHO is called Pyranostructure. So like this, we can also define what is Furanostructure of fructose. Now it is easy to memorize Pyranose and Furanose. Remember FF. F stand for fructose, F stand for Furanose. So for fructose, it is Furanostructure. Next is Furanostructure. Next is Furanose. Furanostructure. Now furan has a structure like this. This is furan. So fructose, it has the structure CH2. Write it like this. COH, CH2OH, 3, 4, 5, 6. Right, left. So number the carbon atom. This one is C1, this one is C2, C3, C4, C5, C6. Here, a alcohol OH group at C5 position has attacked the keto group. So it is hemiketal. So this is a hemiketal structure. Now draw this. Okay. So this one is your C2 carbon, 3, 4, 5. Like this. So on C2, OH is on the right, so it will be below. This is basically alpha D fructose. The alpha form has OH on the right hand side. So you write here CH2OH. For the third one, OH above. For the fourth one, OH below. For the fifth one, H, CH2OH. So this is the Furanos structure of fructose. And all this structure, this one and the previous one, they are called Haworth structure. Next, we will move on to the disaccharides. In our syllabus, we are having only 3 disaccharides. One is sucrose, lactose, and maltose. So let's move on. Another thing before going in the disaccharide, here you can see the linkage is between C5 and C2. So whenever you will define this Furanos structure of fructose, you will say the 5-member cyclic structure formed. Let me write it. Furanos structure is the 5-member cyclic structure of fructose. 5-member cyclic structure of fructose formed by hemiketal linkage between C5OH group and C2 keto group. Okay. So this is how we define Furanos structure of fructose and Pyrano's structure of glucose. Next, we will move on to the disaccharides. Disaccharide, SACCHARIDE. So the first one is sucrose, SUCROAC, sucrose. It is made up of alpha D glucose and beta D fructose. And the linkage is between C1 of alpha D glucose and C4 of beta D fructose. The second one is maltose. Maltose, it is made up of alpha D glucose and alpha D glucose. So both are alpha D glucose. Here also the connection is C1, C4, C1 and C4. Okay. Sorry, for sucrose it is C1 and C2. C1 and C2, and because of that only it is non-reducing, these are reducing. The third one is lactose. Lactose is made up of galactose and glucose. Galactose and glucose. It is beta D galactose and beta D glucose. Beta D galactose and beta D glucose. Here it is C1 and C4. So in all this, you can go through the structure. I can also show you the structure of this. Now, one thing you have to see, in case of maltose and lactose, the C1 carbon atom of glucose and galactose is blocked. The C1 carbon is the aldehyde group. Here also it is the aldehyde group which is blocked. But in case of the other glucose, the C1 is free. That means the aldehyde group is free here. CHO is free. So this will reduce Tollens reagent as well as failing solution. Here also the C1, CHO of this glucose will be free. And so it will reduce failing solution and Tollens reagent. But in case of this one, this glucose is C1 is blocked. CHO is blocked. Here it is blocked. Here it is blocked. But in case of C2, C2 is the keto group of fructose, that is also blocked. For this one, the C1 is free. For this one, C1 is free. Hence, this maltose and lactose, they are reducing sugar, whereas sucrose is a non-reducing sugar, because in case of sucrose there is no free aldehyde or keto group, but in case of maltose and lactose there is a free aldehyde group. In case of, here it is C1 aldehyde group of the glucose, here also it is the C1 aldehyde group of the glucose. Now you will be asked, what is meant by glycosidic linkage? Glycosidic linkage. Let me draw the structure, then I will give you the definition. H, OH, OH, H, OH, H, OH, H, CH2OH, H. This is alpha D glucose, alpha D glucose. Okay. Now let's draw the fructose, beta D fructose of C2 carbon. This carbon is our C2 carbon, so it is beta, that means the OH is above, CH2OH below, this one OH below, this OH above, H above, this one is below, no sorry, 2, 3, 4, this is 1, 2, 3. Third carbon, it is OH above, below, OH, H, H, CH2OH. Okay, so this is beta D fructose. Okay. Now this alpha D glucose and beta D fructose, they can combine together in a reaction called condensation. That means one water molecule will be removed. One water molecule will be removed. And there will be a linkage between this and this through a oxygen, this oxygen. So let me rub it off. So this oxygen will connect these two. And this connection is called glycosidic linkage. So how we will define? We will define like this. The oxide linkage between two monosaccharide, the oxide linkage between two monosaccharide in a disaccharide or a polysaccharide is called glycosidic linkage. Okay, it's called glycosidic linkage. It is formed by the loss of one water molecule. It is formed by the loss of one water molecule. So it is basically a condensation reaction. In polymer chapter, you will study condensation polymer, where one water molecule or a small molecule like ammonia is being removed. So wherever a small molecule is removed, we call it condensation. Okay, so I am not drawing the structure of lactose or maltose, that you can draw it from the NCERT book itself. So next we will move on to the polysaccharide. Polysaccharides. Now in polysaccharides we will study, first is starch. Starch is the main storage polysaccharide in plant. Main storage polysaccharide in plants. Okay. Now starch has got two parts. One is called amylose and another is called amylopectin. One is amylose, another is amylopectin. How we will differentiate? 15 to 20% of starch is amylose. 15 to 20% of starch. Here it is 80 to 85% of starch. Okay. Second point, amylose is water soluble. Water soluble. Now why it is water soluble, that also I will tell you. Second, here it is water insoluble. Okay, so whenever we buy the instant starch Revive from market, those instant starch usually contain the amylose part, because the moment you dissolve it in water, it becomes soluble. But originally the starch is not completely water soluble. Only 15 to 20% is soluble. The rest is insoluble starch. And the insoluble material is amylopectin. Now, starch is a polymer of alpha D glucose. Starch is a polymer of alpha D glucose. Okay, this amylose is a straight chain polymer. Straight chain polymer. This amylose is a straight chain polymer which is formed by linkage between C1 and C4 glycosidic linkage. C1 and C4 glycosidic linkage. But in case of amylose, it is a branch chain polymer. Amylose is a branch chain polymer. Chain polymer. Here the linkage is C1-C4 for linear by straight chain For branching, it is the C1, C6 is used for branching. Now more branching takes place, the structure become more and more spherical, and the OH group which is there in the glucose, they become less exposed to the water. So they form less number of hydrogen bond and hence it become less soluble. Once again I am telling you, as the number of branching increases, the molecule become more spherical, and the OH group on the alpha D glucose, they are not exposed to the water molecule. As a result, this form less number of hydrogen bond with water and hence they are water insoluble. Okay. Next we will move on to cellulose. Next is cellulose. Now cellulose is a straight chain polymer of beta D glucose. Straight chain polymer of beta D glucose. Cellulose is a straight chain polymer of beta D glucose and it is the main structural part of the plant kingdom. Cellulose is the main structural part of plant kingdom. Here the linkage is C1, C4 glycosidic linkage. Okay. The third polysaccharide is glycogen. This is animal carbohydrate. This is also called animal starch. Because it has resemblance with amylopectin. It has resemblance with whom? With amylopectin. But it has more branching than amylopectin. Has more branching than amylopectin. So it is water insoluble and it is present in liver. So during starvation or during less consumption of carbohydrate, our body uses this glycogen from liver and it converts it into glucose and provide energy. So this glycogen is the storage energy in our body. It is present in the liver. So with this we complete the entire carbohydrate topic, and next I will give you the set of questions which has appeared in the CBSE exam in last 10 years, and I will give you the question which has appeared in the NEET and JEE-MAINs exam.